Hey guys, so let's go ahead and finish off what we were getting at yesterday's lesson. So, our goal today, guys, is now that we've talked a little bit yesterday about what it means to have mean absolute deviation, now we're going to actually get into finding it. So, keep in mind that the best short to the point definition to use to describe mean absolute deviation is simply that it is the average distance that a data point is from the mean. So you take all the data points, figure out how far they are from the mean, like we did yesterday, and we're figuring out how far left to the left or the right they were from the mean. Take them all, then find their average, where you add them up and divide by how many there are. But we'll get to that in just a second. So what we're going to do first, guys, is we're going to look at two examples today. We're going to look at first an example where you're given data points and you want to compare their means, and then we'll look at another one that gets into actually doing mean absolute deviation, and then we'll get into our assignment for today. Okay. And guys, this should be posted on our Google Classroom page under 4/8/2020. And there should be again, as usual, typical day, you'll see a notes section and a homework section. And again, should be able to type on it. We're still working those kinks out. We'll get it figured out, guys. It's a process, but we will get it done. We'll have everybody in the best situation they can be to learn as best as you can. So let me know anytime you have an issue with it, and we will keep working and we will get this all figured out, guys. So we're going to start with an example, and I'll just go to show us what it's looking like here. We're going to look at this side right here. It says lesson 11 at the top, and it gives you a table, and then they have question 4, 5, and 6, and then another example below. So let's just read it and see what it says. It says, your little brother asked you to replace the battery in his favorite remote control car. The car is constructed so that it is difficult to replace its battery. Your research of the lifetimes in hours of two different battery brands, A and B, shows the following lifetimes for 20 batteries from each brand. So the point of it is you really don't feel like having to change that battery too often because it's not that easy to get to. So you figure, well, I better make sure I replace this with a good quality battery so I can change this as little times as possible, right? As few times as possible. So they give you a table and they label the top row A, top row B, and they give you how many hours each battery lasts. So it says on number 4, to help you decide which battery to purchase, start by drawing a dot plot of the lifetimes for each brand, sorry. Well, if I just kind of take a look through here, guys, it's kind of, there are different ways you could go about doing this. Really, it's just up to you how you want to do it. But guys, typically, if the numbers stay relatively close together, like if the range is pretty small enough where you could put each possible data point down in your paper, you can just go ahead and do that. I do that a lot, guys, when I'm doing these. It's really up to you on that. I think just for kind of for this case, I think the best thing we could do is actually work on ranges, though. So let's just kind of look at A, because A is a little bit stretched out. So let's just see what they give us. They do us a favor. They start with 12, and they go in order. Again, they're being very, very kind here, giving us the numbers in order, simply because now we don't have to fish back and forth and be like, okay, wait, is this the smallest number, or is there maybe another one on this list, right? Or is it the biggest, or am I missing something? So they're doing us a favor so far. Eventually they'll start mixing them up, but got a nice, easy setup for right now. Okay. I am going to just, again, guys, you don't have to make a range on this dot plot. It's not mandatory. But I personally am going to do that because I like to see us get as much practice as possible as we can with estimating accurate locations for where points should go if they're not labeled on a plot. Like if you have a 14 you need to plot and there's not a 14, let's see how well we are at estimating the right spot for it, which we're pretty good at in class. So I think this will be pretty easy for us. But if I look at the tables on A, or the values for A, the lowest value is 12 and the highest value is 27. So me personally, what I'm going to do here is I'm just going to count by fives. And if my range is 12 to 27, I think it'd be pretty safe to say let's start with 10 and count by fives till we get to 30. Then we've encompassed all the values between 12 and 27 with some nice, easy 5 at a time intervals. So keep in mind, guys, when you're doing number 4, that you're going to need 2 dot plots, one for A and one for B. So make sure you're giving yourself enough room to do both of them, one on top of the other. So I'm going to put A at the top, and then I'm going to make a line. Goes all the way across. Since we're making a dot plot. And then I'm going to leave a little bit of space, and then I'm going to put B, and do the same thing, make a line. I'm going to start out like that, A and B. And then I'm going to label them. Like we said, I'm going to start with 10s. And then I'm just going to count 5 at a time, so 15s. And again, this doesn't have to be totally perfect on this, guys. Mine is definitely far from it, but it's okay. As long as what you're doing makes sense, as long as you can get a good estimate, just try to get it to stretch a decent way across. I probably could have got mine, or I definitely could have gotten mine to go a little further, but that's okay. Just make sure they're spaced out where it's easy to understand where each number should go. Okay. So now all you gotta do is just start making the dot plot for it. And if I look at A, I start with 12. 12 is pretty close to the middle of 10 and 15, but a little bit closer to 10. So remember my advice, guys, when you're making a dot plot, just cross them off as you write them. Then I got a couple 14s. Should be right in front of 15. Nice 15. That'd be right on top of the 15. And the 16 is next, right after the 15. Again, nice and helpful. The next number is 17. That's just one bigger than 16. So I could just put that X right beside the 16. And I got 2 of them, 2 17s. So cross them off. Again, 18 will go right beside the 17. And there's only one of them. And then I got 19 next, right beside 18. And then again, nice 20 right above the 20. Then I got a 21, a couple of 23s. Looks like I got 1, 2, 3 24s. A 25, a 26, and a 27. So my dot plot on A looks something like that. Fairly spread out, right? It goes pretty far across the dot plot. I'll put it back up in a second for those of y'all that need to check again. I'm going to go ahead and do the B's dot plot here. So for brand B, this one is going to be a little more bunched up, it looks like, than the other one, because on A, it goes from 12 to 27. On B, it only goes 18 to 22. So this is going to have numbers that are way more close together, or way closer together than A's were. So, and probably, since they're so scrunched together, you're probably going to get taller stacks too, right? Because if there's not much space to spread out, the only way to go is up, right? So, got a couple of 18s. Mark them off. I got a lot of these. I got 1, 2, 3, 4, 5, 6 19s. 1, 2, 3. You can count 1, 2, 3, 4, 5, 6 when you mark them off and make sure you don't miss one. I got 1, 2, 3, 4, 5 20s, it looks like. 1, 2, 3, 4, 5. Cross off 1, 2, 3, 4, 5. Again, I got a lot of 21s. 1, 2, 3, 4 21s. 1, 2, 3, 4. Cross those 4 off. And then I have made a dot plot for brand A and brand B. Okay. So that's what my dot plots look like. something similar to that. If you spread your paper, if you spread your numbers further out across the page, it'll look a little more spread out than mine. Again, mine's not totally perfect, but the point is made. The idea is, if you look at it, it clearly looks like the numbers for B are more consistent than A because B's are closer together than A's, right? So let's get to the next part. It says find the mean battery lifetime for each brand and compare them. Okay, I got brand A and I got brand B. Okay, how do we find mean? 2 steps. First is add together. Second is divide by how many there are. So I'll save us a little bit of math here, guys, because again, this is definitely a situation where you need to have a calculator. I would hate to be the one that had to be sitting there adding all these up by with paper and pen. But fortunately, I've already added these up earlier, so I am just going to show a work real quick that I'm adding every number in this list up to the 21. I've got 2 of those, and then I have a couple of 23s, and then there are my 3 24s. Then I have my 25, my 26, and my 27. And according to the data, I have 20 data points. So let's just check and make sure I got 20 on my list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so I got them all those numbers, all added up. Look at all that work. Now, again, guys, you know how to do mean, not too big a deal. All I did is write those down. If I had a calculator in front of me and I added them up, I should get about 400. Okay. Now, how many numbers are there? 20. So to get the mean, I'm just going to go ahead and do 400 divided by 20, and I get a mean of 20. So on brand A, I have a mean of 20. Because 20 times 20 is 400, right? Now B, I got 18 plus 18 plus 19 plus 19 plus 19. Got a lot of 19s. Plus 19 plus 19. It's 1, 2, 3, 4, 5. So one more. 19. And then I got 5 20s. So 1, 22 20s, 3 20s, 4 20s, 5 20s. Okay. And then I have 1 21, 2 21s, 3 21s, 4 21. And then I have finish off with 3 22s, 22, 22. Again, there's supposed to be 20 batteries to check on this. So count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So again, on B, right down here, there's all the numbers for B. Again, guys, conveniently, if I add all these up, I get a nice, easy answer of 400 again. Well, looks like we have a situation here. Because if I find the mean, I just do 400 divided by how many numbers there are, which is 20. Well, look at there. Brand B has the exact same mean as brand A. They both average 20 hours per battery. So if you had that battery running constantly, it would last 20 hours, 20 hours on average. Okay. So 6 says, looking at the variability in the dot plot for each data set, give one reason why you might choose brand A, and then what is one reason you might choose brand B, and explain your reasoning. Because, guys, the great thing about statistics that I like about them is that it's a lot of open to opinion. Yeah, one might seem kind of obvious that it's better, but in a lot of times you can make an argument for both cases. So really, it kind of allows for some individuality. It kind of depends on what your preferences are. If you're a risk taker, maybe you want the one that's not so consistent, trying to go for the big one. Or if you're just kind of like to be the one that kind of plays it safe, then you might go for the more consistent one. So we'll talk about the advantages to both. So we'll leave a spot for both on number 6. So we got a spot for brand A, and we're going to leave right underneath it a spot for brand B, and just kind of give a quick explanation about advantages to both of them. Because first off, it says look at the variability. So if you look at the variability, real quick, we've been talking about variability this week. Well, I'm going to kind of get into a different idea on this question. Clearly, A has more variability than B because B is nowhere near as spread out as A. So B has less variability, so it's more consistent. So let's just talk about advantages, though. So we want to give a reason why I would want to choose, even though brand A is more consistent. I know I marked these off, but we can still see these. If we look close, we'll still see the numbers. And you have them in front of you too, guys. Make sure you can still see them if you haven't yet crossed them off. You can still cross them off, but make sure you can still see them. But look at A. Let's just think about advantages to A. The average is the same as B. They average 20. But let's think about A. Again, if you look at A's numbers, if you're a risk taker, you probably want A because, yeah, the average is 20. But look down here at B. It never gets above 22. Look over there at A. I see several options where I can get above 22. There are several opportunities to get above it. Now, that being said, there are also, if I look on the other side of this data set, there's also several opportunities to be less than the lowest amount on B. Look at B, the lowest amount's 18. There's several numbers right here that are less than 18. So it is a very risk-reward situation if you want A. So if we want to give a reason why we might pick A, I would just say that there are several chances to get a long lifespan. I guess we'll just call it lifespan. Doesn't really matter. Battery life, lifespan of a battery. Doesn't really matter what to say there. So again, on A, maybe the advantage would be that there are several chances to get a battery with a long lifespan, because there are. But again, you run the risk of also picking one of the several batteries that have a lower lifespan too. So that's kind of your choice there. Maybe it'll be worth it, or maybe you are needing a guarantee of you need at least 20 hours or 25 hours on a battery life to make something work. So you're going to have to just take the risk and go for A and hope you pick one of those few that are above 25 or at least 25. Because if you don't, B, yes, it's nice and consistent, but it's never going to get above 22. So maybe it's just a risk you have to take. Sometimes in life, you just got to take a risk. So maybe that might be why you might want A. So if I look at B, let's think about why we want B. Well, again, if we pull up B, the great thing about B is my numbers on B stay really close together. If I look at all these numbers, they all stay between 18 and 22. The lowest is 18, the highest is 22. So if you're just needing a nice, reliable battery that you're never going to be surprised what in a negative way what the average is, or really you won't be too surprised either way because it doesn't fluctuate too far from 20, you're probably going to want B. So for B, maybe an advantage, I don't know. There's a lot of ways you could word it, but maybe we could say B has more consistency with its battery life. So there's B. We're going to explain B. It has more consistency with its battery life. If you're asking me what my preference, I like to go with a safe bet for the most part. I would rather pick something reliable. If I'm in a desperate situation, maybe I'll pick one that has a chance at a higher amount. But typically, I take the more consistent route. I don't mind playing it safe. So I would, if I were to personally pick one, I would have gone with B. But there's not a right or wrong answer to this question, guys. It's, again, a matter of preference. So that's the first one. So that was a situation, guys, where we had two that had the same mean. They both had a mean of 20, but clearly each one has an advantage over the other one, depending on your preference. Okay. So now let's look at example 2. We're going to look at example 2, and then we're going to get right into the big thing we're looking and trying to understand over the past 2 days. How to find the mean absolute deviation. So let's look at what example 2 says, and it's going to help lead us into exercise 7 through 9. So it says comparing distributions with different means. Well, it says you have been comparing distributions that have the same mean but different variability, like those 2 dot plots we just looked at. A's dot plot was super spread out. B's dot plot was pretty close together. Their variabilities are clearly different because one is more stretched out than the other. That's what we just looked at, okay? As you have seen, deciding whether large variability or small variability is best depends on the context and what's being asked. Exactly like we just said, it all depends on preference and scenario. If you just need a nice, consistent, I just got to make sure I have one that's something around 20 hours of battery life, I'd probably say you probably need to pick B because you have a lot better chance of being really close to that. Now, if you're saying, again, if we're saying I got to have one that has over 20 hours over 22 hours of battery life, well, the only option you're going to have for that is A, and you're going to have to just take a chance with A and hope you get that battery that was one of the longer lasting ones. So all depends on how it plays out, right? So that's really what they're getting out of that sentence right there. Then it says, if 2 data distributions have different means, do you think that variability will still play a part in making decisions? Well, here's a scenario. It kind of depends on what they're asking for. Now, maybe it's a situation where you need it to be a certain amount. And again, it's a matter of, is the more consistent one worth it? Or is it one where we're going to have to take a chance? It really just all depends on what you need. Your needs, your wants are going to determine what's the best choice. So let's take a look then at exercise 7 and 8. It says exercise 7 through 9, but we are just going to look at 7 and 8 on this. And that should set us up pretty well for the assignment for today. And we will clarify that too just a little bit, guys, because if you have the paper packet, there is a problem that we're not going to do on that. So please make sure you follow carefully and don't do the wrong one so you don't do extra work that you don't have to do. Okay? So if I look at 7 through 9, it says, suppose that you wanted to answer the following question. Are field crickets better predictors of air temperatures than katydids? Both species of insect make chirping sounds by rubbing their front wings together. That'd be something we know. The following data are the number of chirps per minute for 10 insects of each type. All the data were taken on the same evening at the same time. So they give you a table, and this is the sheet we're on at this point. We are on the lesson 11 side that has 7 through 9 at the top, and they give you some data on katydids and some data on grasshoppers. Or sorry, not grasshoppers, sorry, crickets. Crickets and katydids. And on number 7, it says draw dot plots for these 2 distributions using the same scale, going from 30 to 70. Visually, what conclusions can you draw from the dot plots? Well, once again, we're going to have to make 2 dot plots, just like we did on the last one. So, kind of like brand A, brand B, this time we got 2 dot plots. And I'm going to call one of them crickets. And they gave us, fortunately, a lot more room to do it this time for these dot plots. So one will be crickets, and then the one below it will be the katydids. And we're going to make dot plots and then look at mean absolute distribution. We're finally going to get to how do you do this. And it's really not too hard, guys. Just a matter of getting there. So we're almost there. Let's just see how to do this part first. So if I'm looking at these, it all depends on the distributions that you see. If I'm looking at my data, what I want to do, if I'm going to give a nice, reliable comparison of these two dot plots, I don't want to just consider one dot plot's distribution. I want to look at both of them and give them both the same scale so I can really see how one compares to the other. Because if I don't do that, if I just use a scale that fits each scenario where they have a different scale, I can't really look at it and get some clear ideas since they are using different ranges. One might look bigger, but that's because it might have a smaller range. So when we do these, we're going to have some dot plots with some pretty big ranges, because if you haven't noticed yet on the table, the numbers for the chirps for crickets versus katydids are noticeably different. So let's take a look into this and see what we get. So if I look, I'm just going to find the smallest number and the biggest number and figure out what's the best range to plot. So if I look through crickets, since crickets have clearly smaller numbers, I'm going to find their smallest one. And it looks like for crickets, the smallest number in that table is a 32. So for crickets, I get a 30. Oh, that's 35. Not the easiest to see these backwards. So 32 for cricket is the smallest. And then if I look for the biggest one on katydids, it looks like the largest one on katydid is at 68. So my range seems to go anywhere from 32 to 68. Well, if I'm going to come up with a nice range for that, again, I like to either go by 5s or 10s. It doesn't really matter which one. I think it just kind of depends on how well you can fit it on here. How about for this case, let's go ahead and do it. Let's do it by. Let's see if we can make 5s fit. Let's see if we can do it. Now, if I go from 32 to 68, the best one to start with is probably 30 because it's just a little bit under 32. And if I'm going up to 68, 70 is probably a nice stopping point. So let's just see if we can fit that on here. So I'm going to start both of these with 30. And I'm going to make sure to give myself the entire page to draw this number line on, because we got several numbers we're going to put down here. But it's going to help with our ranges a bit. It's going to help accuracy when we're estimating. But obviously, guys, you don't want to go 32 to 68 because that'd be a lot of individual numbers to write down. 32, 33, 34, 35, 36, 37, 38. That would take forever. So that's why we're skipping just a little bit, because it makes it a little easier to put the dot plot together. So on each one, I'm going to start with 30. And I'm just going to go 5 at a time. So 35, 40, 45, 50. I could probably spread it out a little bit more. Again, we're estimating here, guys. So sometimes you might over or underestimate the amount of space you give, but just kind of do the best you can to stretch it out. It's okay if you're not perfect on that. So 60 and 60. And please make sure you don't skip one, because that'd be a big mistake. 65. And then I'm going to wrap it up with 70. And that was pretty good at going decently far across the page. Because if I take a look here, I'm going to check and make sure I didn't make a mistake before I look silly up here. So it looks pretty good. So I have my 2 dot plots for crickets and katydids going by 5s all the way from 30 to 70. So that should be a nice range to plot all the numbers I need. So I'm just going to finish off the dot plots. Keep in mind, guys, I'm not too picky about how you do these. You can use X's if you really want to. I'm going to stick with dots for now just because they call it a dot plot. So if I go through these, If I start with crickets, I got 35. Actually, you know what? I'm gonna go with X's on this. Actually, it doesn't matter, but I find X's easier to see, so I'm gonna just write X's. So 35, and let's see, I got a 32. I don't think we really need much explanation about how to estimate the locations anymore, guys. So I'm just gonna go ahead and keep writing them. Then I got a 35 again, and then I have a 37. Two 34s in a row. It's nice and easy. So two of those right on top of the other. 38 should be right beside that 37. 35 again. Haven't had a 36 yet, but there's one. And then a 34 again. So I'm going to check myself real quick and make sure I put them all in the right spots. What I'm seeing here is I see 132. Got that. I see 334s. And I'm looking across my table. 1, 2, 3 of those. I see 335s, and on my table, 1, 2, 3 35s. And I see a 36, a 37, and a 38. Well, there's a 37, there's a 38, there's a 36. So if I'm making my dot plot for crickets, it should look something like that. Now, if you notice, you might ask, well, it sure seems like a waste of a range because you didn't let it kind of go all the way across. Like, what's the point in having all these numbers over here? Well, we're going to see why on the next one. So if I look at the next one, katydids. On theirs, start with 66. So it's going to be way over on the right. And then 62, 61, 64, 63, 62 again, 68, 64, 66, and then a 64 again. So again, I'm going to check myself and make sure I did this right. If I'm looking for accuracy here, I have, let's see, 162. I see a 62 in my table. I see two 62s on my dot plot. I have two 62s in my table. I see a 63 on my dot plot, and there is 163 in the table. I see 1, 2, 3, 4 64s on the dot plot, and there are 3 64s in the table, so 3 and 3. I see two 66s on my dot plot and two 66s in the table. And last but not least, I see a 68 in that table. So there's all of my data plots again. So now I have both of the dot plots done. Okay, we can clearly see, now we can clearly see some differences between these two dot plots. One of them has most of its data on the left side, if you're looking at crickets, and if you look at katydids, most of the data is on the right side. But again, this is useful because it's clear now, once if we use the same scale, that one of them is predominantly on one side of the data and one of them is predominantly on the other side, right? So now we can kind of compare that. If we're basing it on how often they chirp, crickets seem to do it a lot less often than the katydids do it. So that's one way to look at it. But let's go ahead and look and see a little bit more. And keep in mind, they're just asking which insect is a better indicator of air temperature. And really, it gets it. And first thing we can think about before we even move on to the mean absolute deviation is that a lot of it depends on what are the typical insects for your area. If you're hearing it around somewhere in the 30s per minute, you're probably hearing the cricket do it. If you're doing it in the 60s, probably the katydid doing it. So if we look a little bit further, let's get into the idea though of mean absolute deviation. Because remember, mean absolute deviation is getting into the consistency. How consistently close is it staying to the mean? So now we're going to jump right into how to find them. Number 8, the last one we're going to look at for the notes here before we jump into our assignment, says calculate the mean and mean absolute deviation for each distribution. Well, let's start with crickets. I'm going to start with the crickets. And then I'm going to, after that, worry about katydids, but let's just go with the crickets first. So mean. You can't do mean absolute deviation unless you know the mean first. So let's do the one that we've known for a while now. Let's figure out how to find the mean in this situation. So according to my mean, here's my data points. I have a 35 plus a 32. And I'm just reading it straight off the table. Plus a 35 plus a 37 plus 34 plus 34 plus 38 plus 35 plus 36 plus 34. Again, if you look at your data table closely, there are 10 recordings of how often the insect chirps. So I should have 10 numbers being added together on my mean. And if I check, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's all my numbers for the mean on the crickets. Now I just need to add them all together. So I'm going to do that real quick. If I throw up my calculator, 35 plus 32 plus 35 plus 37 plus 34 plus 34 plus 38 plus 35 plus 36 plus 34 should give me a total of 350. Well, if I take that number, 350, and divide by how many I have, there are 10 recordings. So 350 divided by 10, you can either do it in a calculator, or you can remember if you divide by 10 and there's a 0 at the end of the number, just take that 1 0 away, or just take a 0 off the end of the number if you can. Well, you can do that because 350 has a 0 at the end of it. So if I divide it by 10, I'll just take that 0 off the 350, and my mean will be 35 on the crickets. So the cricket mean is 35. That is extremely important if I want the mean absolute deviation, because now I got to figure out how far each one of these numbers up here is from this mean. So here's what I'm going to do, guys. What I'm going to do is I'm going to put how far each one of them is from the mean up above each number. That'll probably make it a little easier to follow. I'm going to also just kind of separate it from the problem above so you don't get those numbers mixed up. But again, let's just start looking at them. If my mean is 35, the first number on my list is 35. How far is 35 from 35? 0. They're right on top of each other. So I'm going to put 0 above the 35. Then, if I look at the next number, 32. How far is 32 from 35? 3 away. Okay. And then 35. Once again, 35 is 0 away from 35. Next one's 37. That is 2 away from 35. 34 is the next number on my list, and it is 1 away from 35. The next number is 34. It is also 1 away from 35. Again, all I'm doing is going right down my list of numbers that I'm adding and saying how far are they from the mean. 38's next. It's 3 away from 35. 35 is next. It's 0 away from 35. 36 is 1 away from 35. And 34 is also 1 away from 35. So, and I'm just going to fold this up a little bit so that we don't get it mixed up with the paper above us and get a little bit confused here. So here's what I have. All I did was I wrote how far is each number from the mean. And now, if I want the mean absolute deviation, I got to find the average of these numbers. The numbers up here, the 0, 3, 0, 2, 1, 1, 3, 0, 1, 1. I'm going to find the average of that list. Well, remember, if I want to do it, I got to add them up first. So I'm just going to put a plus sign in between each one. So plus, 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 and plus. And what I'm going to do is I'm going to take that list and I'm going to add all 10 of those together. 0 plus 3 is 0. Plus 0 is still 3. Plus 2 is 5. Plus 1 is 6. Plus 1 is 7. Plus 1 is 10. Oh, sorry, plus 3 is 10. Plus 0 is still 10. Plus 1 is 11. Plus 1 is 12. So the mean, if I add all those up, I end up getting a 12. Okay. So I added them all up. I got a 12. Now, is that the average of this list up here? No, because what did I forget to do? I forgot to divide by how many numbers I just added. So I'm going to take this and put it over here, and we're going to do that. So just so we all kind of understand what's going on here, I'm going to go ahead and get the mean absolute deviation. I'm going to write that down. Mean absolute deviation. And I'm going to do it by going 12 divided by 10. That should give me a mean absolute deviation of 1.2. So once I calculate it, my mean absolute deviation for the crickets is 1.2. That means on average, the numbers in that list are 1.2 away from the mean of 35. So that seems pretty good. They're staying pretty close. They're not very spread out, which would make sense. You'd expect the chirps for the crickets to probably stay pretty close together. So there's that. So I know the crickets have a mean of 35 and a mean absolute deviation of 1.2. Okay. Let's see if katydids are more reliable. If they are more reliable, they're going to have a smaller mean absolute deviation because that means on average, the numbers are staying closer to the mean. Okay. So let's do the one for katydids. Wrap this up. All right. So I'm going to start by finding the mean again. I go for the mean. I got to add my numbers up. And if I look at my list off my table, I have a 66. I have 62 plus a 61 plus 64 plus 63 plus 62 plus 68 plus 64 plus 66 plus 64. Okay. Again, if I did that right, I should have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So let's go ahead and find the mean again. I'm going to throw in my calculator. I have 66 plus 62 plus 61 plus 64 plus 63 plus 62 plus 68 plus 64 plus 66 plus 64. Gave me a total of 640. I put those in right, which should be good. If I put that in, I got a total of 640. And remember, if your total is 640 and you want the mean, you got to divide by how many there are, how many data points you collected. And in this case, you collected 10 of them. So 640, if I want the mean, 640 divided by 10. Once again, we have a number that ends in or is being divided by 10, and the number is ending in a 0. So if you want to divide by 10, you can either throw in your calculator or just take that 0 away. If I take that 0 away from 640, I end up getting a mean of 64. So there's my mean. On the katydids, it ends up being 64. So quite a bit higher than the cricket one. Almost 30 higher, 29 more than the cricket. Well, that sounds fine, but again, think about this. Does it...
Sorry, something went wrong.
Sorry about the Alexa notification. But anyway, so if we're getting into this, kind of the idea, a lot of times you'll think, okay, more is better. Is more technically better here? Probably not, honestly. Does it matter how quickly the insects are chirping? Not really. If you know which one's which, it shouldn't really matter. So if we look at this, guys, it's not the amount of chirps that really are making a difference here. It's just how consistent are the chirps happening, because you'd rather have if you're relying on an insect for something, you'd rather have the one that has the most consistent amount or the most consistent numbers to whatever it's doing. So while it's nice that the katydids are quicker, maybe maybe it's easier to just figure out, oh, that's that one's going pretty quick. That must be katydid. Might be nice to help you notice something, but it doesn't make it the most reliable one yet. Maybe it will be. It all depends on what the mean absolute deviation is for it. So let's take a look at this and find the mean absolute deviation on the katydids and see if they are a more reliable insect to use than the crickets are. Well, I know that my mean is 64. So I'm going to just cut this off again, and I'm going to fold this again so we're not getting confused, because I know we got a lot going on here, guys, and I do not want anybody getting thrown off by all the stuff written down. So I'm just going to fold this down here. Keep in mind that 64 is my average, and I'm going to go through here and right above it how far away each one of these are from the mean. Let me think here for a second. Actually, the way I wrote this, I think I'm going to actually write it down below here. I think that'll be a little easier to read when I finish it off. So I'm going to write the distances below or underneath each number compared to 64. Well, 66 is 2 away from 64. So is 62. It is also 2 away from 64. 61 is 3 away from 64. 64 is 0 away from 64. 63 is 1 away from 64. 62 is 2 away from 64. 68, kind of differentiated here. That one doesn't seem like much for being 4 away, but that's a pretty good amount in this scenario. That 68 is 4 away from 64. 64 is 0 away from 64. 66 is 2 away from 64. And 64 is 0 away from 64. So there's all the numbers down there. Made my list here. Now I'm just going to take them and add them up and see what I get. So let's see. 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 0 is still 7. 7 plus 1 is 8. 8 plus 2 is 10. 10 plus 4 is 14. 14 plus 0 is still 14. 14 plus 2 is 16. And 16 plus 0 is still a total of 16. So I'm going to take that 16. I'm going to use it to find my mean absolute deviation. So there's the 16. A little sloppy, but that's okay. There's 16 right there. I'm going to move it over here and write down what my mean absolute deviation is. So for katydids, they have a mean of 64. But on their mean absolute deviation, which, guys, a lot of times you'll see a mean absolute deviation abbreviated as MAD, all caps, a lot of times. But our mean absolute deviation, MAD, if I were to find it, I need to take that 16 and divide by how many data points I have. I have a total of 10 data points, so 16 divided by 10 equals, again, you can use a calculator if you want. If you throw it in there, 16 divided by 10, just kind of recap of when you're dividing by 10s. Dividing by 10 is taking your decimal and moving it to the left one time. Well, if I do that, I have my decimal at the end of the number, right after the 6. So if I move it back, it goes between the 1 and the 6. So 16 divided by 10 is 1.6. So my mean absolute deviation for the crickets is 1.6. So what does that tell me in the kind of the grand scheme of this? Simply what it tells me is if I take that information and now I'm going to just look at both of these put together, if I just want the more consistent insect, I am going to want the cricket, because the cricket, on average, its numbers are only about 1.2 from the mean if you put them all collectively together. While the katydid, while it might not, if I can find it, while the katydid, while it might not seem significant, its mean absolute deviation is a 1.6. And if I'm strictly just asking which one's the more consistent insect, it's got to be the cricket, because the number is just slightly lower. Now, is that saying that katydid is not very reliable? No, not really, because it's close. I mean, I'm not going to complain too much with an insect having the mean absolute deviation of 1.6 when I'm just comparing it to 1.2. 0.4 isn't much different. It's not too much of a surprise. And you also have to consider that the katydid has larger numbers, so maybe that 1.6 isn't quite as significant of a difference since the amount is higher. It just kind of depends on how you want to interpret it. So, but that's all they asked for in that question. Now, they probably will end up getting to which one's more reliable, and so I'll just probably write that down. I would probably just put at the bottom that the cricket has smaller MAD or mean absolute deviation, so it's more. I would say it's more reliable. Would be a good way I would write it. There's other ways you could interpret it too, but that's all I would say about it. So at the very bottom of the page, underneath the katydid part, I just wrote the crickets have a smaller MAD, which is mean absolute deviation, so they are more reliable, at least in my opinion. But and a lot of times data is open to interpretation, so that's just what I think about it. Now, guys, let's get into what I'm expecting for your assignments for this one, for our 4/8/2020 lesson. So I'm just going to pull it up here real quick, guys. And what I see on there is mine is on the page that has S75 at the bottom. I might have cut that off, guys, but it's just on your 4/8 homework page. I cut it off for those y'all using the Google Classroom. I cut this page off where you're not seeing the extra problem. I'm pretty sure. Almost certain I did that. If not, just keep this in mind. Please ignore question 1 at the top. You do not need to do question 1 at the top of that page. So keep that in mind when you're looking at that page, guys. You're not doing number 1. You're just looking at number 2. And number 2 says 8 of each of 2 varieties of tomato plants, Love 'em and Wonderful, those are the types of the plants, are grown under the same conditions. So same temperature, same soil, same nutrients being added to it, water amount, everything. Not one of them is getting better treatment than the other one, or well, different treatment. Maybe one treatment's better for one than the other, but I mean, who knows? Just keep in mind they're doing the same thing to both of them, so it's kind of a level playing field in that regard. It says the numbers of tomatoes produced from each plant of each variety are shown. They give you data on Love 'em and data on Wonderful. Really similar situation as compared to the katydid and cricket situation. And then basically, guys, they're just asking you to do exact same material for the most part that we just did on the cricket and katydid question. Because if you look through the questions on A through D, number 1 or part A, we did this already. Draw dot plots to help you decide which variety is more productive. So draw a dot plot for the Love 'em one and draw a dot plot for the Wonderful one, and figure out which one do you think is more productive based on the dot plot. And maybe write a sentence to explain why. On B, calculate the mean number of tomatoes for each variety. Which one produces more tomatoes on average? Pretty easy. Find the average, figure out which one produces more. Make sure you find the average for Love 'em and the average for Wonderful. C says if you want to be able to accurately predict the number of tomatoes a plant is going to produce, which variety should you choose? The one with the smaller MAD or the one with the larger MAD? Explain your reasoning. I think based on what we talked about, that one should be a pretty straightforward explanation. You could probably explain it in 1 or 2 sentences tops. Not much to that one on C, but I think it should be pretty easy if you pay attention to what we're talking about in today's lesson. And then D says calculate the MAD or mean absolute deviation of each plant variety. Again, we just talked about how to do that. That's what we did at the end of the cricket and katydid problem right after we found the mean. We found the mean absolute deviation, where you figured out how far apart on average are they from the mean. So if you have a question how to do that, go back into the video, look at how I found the mean absolute deviation on that. And that's about it. There should be plenty of room down there to fill that in, guys. If we do end up having an issue with that, guys, please message me about that. Again, we are kind of working with this as we go, kind of monitoring, adjusting this. If you have any issues getting that to fit right, please let me know, and we will change it up if we need to, or maybe just take away, skip some part on there. Maybe just get rid of one so we can at least fit the assignment on there. It looks like we're getting more people straightened out on how to do these documents and type on them. We're going to keep on working on that, guys, till everybody's in a good situation with that and where everyone can turn it in without any problems. So, guys, if you're having any issues with that, keep those questions coming, guys. I appreciate all the input you guys are having, all the messages you are sending me when you have questions about stuff, and I'll be happy to keep on working with you, and we will get this figured out one way or the other with whatever issues you're having with it. Hopefully I've been helpful for you guys in your questions. Please don't get discouraged if it doesn't get exactly the output you're wanting right off the bat. Keep asking me questions and we will get this straightened out. And we will make this a solid end of the school year, guys. Proud of y'all for working as hard as you have, and keep up the good work, guys. And let me know if you have anything else you need, guys. So with that being said, good luck on your assignments, and keep in touch if there's anything that you need me to help you with.